Okay, you are on page 149. Make 5. You are on page 149. Don't make me regret giving you a Twizzler.
I'm already on it.
Again? Okay. Okay, so this is what we demonstrated with our Twizzlers. If we have 2 lines that intersect at one point, that's what we have been finding for the past week. We have one solution. You just turned in a green graded assignment that had a bunch of problems where 2 lines intersected at one point, right? Okay, now, if I give you 2 lines and they are parallel, then you're gonna have no solution. And so when I ask you where these 2 lines intersect, you would tell me no solution. Okay. Now, if 2 lines are the exact same line, how many points do they have in common? All of them, which means we have infinitely many solutions. I don't even know how you make that noise. Oh, nope, we're not going anywhere. Okay, here we go. Now, I feel like on the next page, if you looked at number 1, there is no algebra you're going to have to do. What do we know about these 2 lines?
With the same slope.
Okay. These lines are parallel, which means what would our answer be? No solution. Okay. Now, 9.5 times out of 10, that's not going to happen. We're going to actually have to do some algebra. Okay. So I would like to look at what it looks like when we actually have to do some algebra. Okay. So if we,
Wait, that one even that one.
Hold on. Number 4, can we use elimination?
Yeah.
We already have opposites for the x's. Oh my goodness, and the y's. So what happens? What happens when we add the x's? What happens when we add the y's? So on this left side, we have 0. What do we have on the right side? Connor, does 0 equal 9?
No.
Will it ever equal 9? No. 0 will never equal 9. It never, ever. So this means we have no solution. You know, it would really help if you worried about this at the beginning of class instead of halfway through.
She said she would give me one, but then she
Okay,
No, I asked you.
let's go to number, okay, so what does this mean about number 4? What's true about these 2? They're parallel. So I'm going to go into here. X plus 3y equal plus 3y equals what? 6. There's that line. And we have negative x minus 3y equals 3. We have two parallel lines that do not intersect, so our answer is no solution. Yes.
Well, they're opposite, but now they're for like the same stuff. No, it's just
If they're parallel, they have the same slope then. Are we already ready for a new seating chart?
like, why were they worth it?
That was a good decision, though, too. Separate yourself a little bit. Okay, let's look at number 5. Ooh, is this one ready for elimination? Sure is. Oh, 6x minus 6x is 0. 6y, can I just talk and you not interrupt me? 6y minus 6y, the left side is 0. What's the right side? How many times will 0 equal 0? All the time. Okay. Yep, what does it mean if we have infinite solutions?
They're the same.
They are the same line. So if we go to our Desmos here, what is our first line? 6x. Okay, and then we have negative 6x minus 6y equals 3. Notice how the green and the purple line are the same. So all of the points, they share whatever point I pick. There's an infinite number of points on the line, right, Brooks? So I thought. All right, let's look at number 6. Is this one ready for us to use elimination? Yes. Okay, if we use elimination, then we get 5x equals 5, so x equals 1, right? And if we take that and we plug it in, 3x plus 5y equals 8. What's y?
1.
So our solution is 1, 1. These two lines are not special. They intersect at exactly one place, the coordinate 1, 1. Okay, so let's look at that. If I type this in, you're not even on the right page. Like, not even helpful, dude. 2x minus 5y equals negative 3. And then over here, we have 3x okay. There are our two lines intersecting at 1, 1. What I would like you to do is try number 8.
Here, are you even on the web page?
Yeah. Did it lock it, put it in your pocket?
That's good.
My guy's in there. Yep, I'm still there.
As he should.
Okay, in order to solve this, who used substitution?
Oh, wait.
You use substitution, really?
Wait, no.
Who used elimination?
I got a mixed up, that's not it.
Okay, Drew, when you used elimination, which one did you multiply by what number?
Positive two. Positive.
So when we multiply the top one by a positive 2, we get 8x plus 6y equals 34. So 0 equals 68.
I divided. Wait, what? What? Oh, never mind. I divided.
How many of you said infinite solutions? Yeah, you were paying very close attention because this adds to 0, this adds to 0, but these two add to 68. Hey, is 0 equal to 68?
Why'd you write that?
Why did you write it?
I wrote no solution. It's right there. You never wrote it. It's a hard proof.
Yeah, even I wrote no solution.
Did you? Okay, so Henry, you said you divided this one by 2?
No.
Who said that?
Oh, me.
You did. So you had 0 equals 34. Well, you could multiply by 1/2. So that's on the table. Okay. So I'm really frustrated right now with the number of people who are trying to talk while I am talking. It makes me maybe question whether I should give you work time on your homework or not. So we're going to try this again. How about you try number 9? And this time we're going to be appropriate with our conversations and when we have them. How many of you are using substitution? Probably good. Probably not. I like it in certain cases, but I do like a good elimination problem. Okay, Ellery, what did you multiply which one by? So you have positive 9x minus 6y equals a positive 18. What happens when we add these together?
0 equals 0, so you can choose.
Okay, I feel pretty good about where we are. So this is what I'm gonna do.